The subject of our panel, though, is we're going to talk about this flood of information that's coming from space systems, and it's a lot, and it's coming from a lot of different sectors. How do we utilize this? The first two panels have talked about that in some applications, and we're going to talk a little bit more about it in terms of how do you incorporate these, what are now becoming huge volumes of information that drive you to getting actionable information or intelligence to your user, to your customer. And we have a great panel here with us today. I'll introduce them here in a second. But I also want to give you one other perspective. So when I showed up at the USGS, most people don't know. They think NASA owns the Landsat system, but it's actually owned and operated by the U.S. Geological Survey. I showed up as the director, and of course, I was, again, old enough to have seen the very first Landsat imagery. And as a geologist, those were magical images, right? We could see things at scales that just weren't available anywhere else. And at the time, I saw that first set of images that came off of Landsat 1. It changed my perspective on how you do things with imagery to begin with, but really space-based imagery. So when I became the director of the USGS, I was interested in how much information we had available. And it turns out that we have somewhere around 5 petabytes of information just from the Landsat, 52 years of Landsat information. What does that mean? Well, what does that mean in terms of scale? Well, that's about 330,000 high-end servers in terms of the amount of information that we have. Not only that, it's all calibrated, right? So it's now calibrated, validated, so it's equivalent information. And so that was the first thing that led into how do we manage this? Cloud-hosted systems, of course, revolutionized how we manage data. Now, what do we do with it? And that's the subject of our panel here today is, what are we going to do with this space-based data? And there's semaphore going on up here. I'm not exactly sure what's happening, in terms of there. Okay, good. We're good to go. Okay. So with our panel today, we have a great panel to work with this amount of information that I just mentioned, 5 petabytes. That's just Landsat alone. But think about all the commercial sector that's now bringing imagery to the marketplace. How do you incorporate that? What does it take to normalize that information? And so we're going to get into the AI applications of how we manage this information with the whole objective of how do we deliver actionable intelligence or actionable information at your customer. What does your customer need? And what do they need at the speed of decision? And so our panel includes Winston Tree, who's here on the end. And Winston is the co-founder and the chief product officer at Albedo, one of the companies that is now doing imagery from the commercial sector. That's a piece of the marketplace that you can now apply to what we were just talking about. He supports the sales, product, and software engineering teams, making satellite imagery more broadly accessible. Before Albedo, Winston worked at Facebook as a software engineer. So if you really want an interesting post, to put on Facebook here, we were talking about this earlier, 15 minutes after we're finished with this panel, just go outside, just look up and wave, and you'll get a great post from Albedo. No, I'm kidding. And then next to him is Steve Kitay, and Steve is the Senior Director of Azure Space at Microsoft. And before this position, he was a member of the Senior Executive Service as the Deputy Assistant Secretary of Defense for Space Policy, where he had a key leadership role in the establishment of the U.S. Space Force. And Steve was also an active duty Air Force military officer and has held civilian positions in the intelligence community and on Capitol Hill. And in spite of his appearance, he apparently has a lot of experience in a very short period of time in his short lifespan. And then next to him is Dr. Brent Bartlett, who's a senior solutions architect with NVIDIA. He's also an image scientist who develops software and hardware to provide end-to-end solutions to challenging geospatial problems. Prior to this role, he was chief operating officer at Beam.io and co-founder of Eidetic Technologies, and enjoys exploring the intersection of traditional remote sensing with the emerging AI techniques. And then finally, on my immediate left here is a colleague of mine, Dr. Neil Jacobs, former acting NOAA administrator and early pioneer at Epic and Unified Modeling, and he's worked in both the public and the private sectors for the past 15 years. He has also served as the chair of forecasting improvements for the American Meteorological Society and was affiliated with the World Meteorological Association. So we have a great panel, and we're going to kick off with a few questions, and we'll probably address them to the individuals, but feel free to jump in. Everybody who would like to can offer opinions on this. But I want to start with Neil. And the U.S. government agencies are now acquiring or have available ever-growing volumes and types of information from both government and from commercial providers. And this rapidly expanding commercial industry is now seeking ways of delivering actionable intelligence. So when we look at AI and machine learning applications, which we've been talking about today, how can they be applied to generate integrated data solutions to any customer from these different sources?
Well, a lot of people, I mean, if you've been watching the news lately, you've probably seen everyone talking about AI being used for weather forecasting. And to me, it's a really, really fascinating time to be in weather and climate modeling because of all the new capabilities. But one of the things that I think it's left out of the conversation, whether you're using it for forecasting or not, is the training data sets. And all these AI systems that are actually being used right now to predict the weather, they don't actually forecast the weather. They actually forecast what the model that they were trained on would say about the weather. And that's a big difference because those models can't go away. It's an initial value problem that going forward in the future is probably going to be exclusively initialized from space-based data. And the problem with that is there's really no way to avoid moving the data around, particularly with polar orbiting satellites, because they downlink the data at the poles. And this was a shocking number to me coming from numerical weather prediction world with the tremendous volume of data that we had access to. You'll probably be surprised to know that less than 1% of what is actually thrown at a model gets used in the model. And as the data sets become higher and higher resolution, both in space and time, that number gets much, much smaller. And the reason why is because you need your weather forecast now. It doesn't do you any good to learn what the weather is going to be if it takes me 3 days to make a 2-day forecast. And with the latency issue being so critical in high resolution, rapid cycling models for weather forecasting, the correct choice, but the frustrating choice was made that lower resolution data with lower latency is better than high resolution data that gets to the model too late. And anytime someone develops a more sophisticated sensor that collects higher resolution data, the first thing that runs through my mind is how much more thinning am I going to have to do to get the file size down to where I can get it to where it needs to be in time. And that's where I think we're going to see the mix of AI, not in the prediction side, but in the pre-processing side of the satellite data. And ultimately, I think the Holy Grail would be on edge, where you're actually processing a lot of this stuff on orbit and downlinking the really useful, important stuff. And that may vary day to day, hour to hour, minute by minute, depending on what's going on in the atmosphere. But to me, that's the biggest challenge. And I think a lot of the manufacturers of these instruments are thinking about this. How much data can I produce, high resolution? They're not necessarily always talking to the people who use the data and where they're using the data. So doing a lot of the pre-processing on edge to me is the ultimate. And I really think that you're going to see a mix of edge computing along with AI on orbit to solve this challenge.
Steve.
Jim, if I can build upon the comments that were just made, and first off, I want to say thank you for having me here. Thanks for Booz Allen for hosting it. This is a terrific event. So I just want to add a little bit of context on the remarks about the size of data. And you started off by mentioning the 6 petabytes of data coming off the Landsat satellite. And I went and looked at some of the numbers to try and put context into when we're saying this massive amounts of data, at least even if you just look at Earth observation satellites. So there's about 8,000, little over 8,000 active satellites on orbit today. About 1,200 of them are Earth observation satellites. Now, those numbers are projected to grow anywhere between 10 and 14 times over the next 10 years. So these numbers are going up rapidly from what they are today. If you translate the amount of data coming from these Earth observation satellites into HD movies, like on Netflix, it's 100 billion movies. And if you think about that and just the sheer amount of information in 100 billion movies, and being able to extract information out of that. It's just this tremendous challenge as well as this great opportunity for us.
And I want to so again, thank you for having us at this event. I'm Brent Bartlett from NVIDIA. I kind of wanted to actually build on that even a little bit more. So in my background in remote sensing, we're talking about raw data, but I think if you actually look at the holdings of each of these satellite platforms, it's even kind of compounded. It's worse, right? You have raw data that comes off the satellite, but then we do a lot of processing. We call it sort of like level 0, cleaning, level 1, level 2, etc. And so these derived products that get pulled out of the raw data all get stored as well, right? So we have this kind of compounding storage debt that grows over time. So I think it's good in that it's being made available, but I think it's not sustainable going forward, perhaps, to store kind of like that much data that's just derived from this one source. So one of the things that I think is an opportunity for us is to look at ways to more efficiently store those raw pixels and then rethink the architecture around using tools like accelerated compute to create those products on demand versus sort of like storing everything forever. So
we've sort of heard two things coming out here. One is just the sheer volume of data, and that's going to expand almost exponentially as the private sector gets more and more involved. And we're already seeing that. Second is, how do you manage that so that you deliver actionable information to your customer? Obviously, there are some challenges and limitations, but also capabilities. Would you guys like to discuss potentially how AI ML applications, computing at the edge, which Brent, you brought up, what are those capabilities? What are our advantages? But also, when we talk about computing at the edge, what are some of the limitations that we're going to have to address? Now, that's open to anybody.
So I can start because it does come down to, we're starting this kind of conversation on this panel about starting with the data and then how you use artificial intelligence, machine learning, generative AI, these different tools to then understand the data. The data management is a foundational piece of it. So at Microsoft, one of the areas that we're working on is something called the planetary computer, which is the ability to bring in massive geospatial data sets. So you had mentioned, 5 petabytes earlier. We're currently hosting in the cloud over 70 petabytes of geospatial data across different space systems to then serve as the platform to bring artificial intelligence, machine learning tools on that. So that's in the hyperscale cloud. That's something that, there is tremendous amount of compute and storage resources, which really does then provide this great foundation for these other tools on top of it.
So I guess I'll jump in again. One of the things that I think we're also getting excited, very familiar with planetary computer. It's an awesome resource. I think one of the things that has gotten folks excited about the opportunity of things like generative AI is the ability of the technology to some extent today, it's still very new, to sort of democratize computing, right? So you can now access a computer in a way that you've never been able to before without necessarily needing to know low level like assembly language or Python at a higher level. So I think it'll be really interesting to see where that type of technology goes relative to vision, right? So we're starting to see attention mechanisms start to work well with foundation model building with imagery and remote sense geospatial data. I think big opportunity to sort of democratize insights in a way that hasn't been available before and more easily access the information that are in those, what you say, 70 petabytes? Yeah, so that'd be exciting.
So you bring up the concept of democratization of data, right? What to you, and I'll just start with Winston and come all the way this way on the panel. What does that mean to you?
I think at Albedo, so we're focused on, one, capturing the imagery itself. So, we'll have that imagery in next year once we launch our satellite, but getting that imagery out in front of users in a timely manner. We have a lot of DoD IC folks in the building. that time value, the value of that imagery decreases over time, and at a certain time it falls off a cliff, right? So getting that imagery in front of users when they need to, and them accessing it in the ways that they need to. I think you mentioned formats. Someone mentioned formats earlier, but putting controls in front of the user so that they can specify what kind of data, how fast they need it, and then immediately being able to access that. And that helps with the latency problem, that helps with the usability problem. So I think that in a nutshell in terms of democratization is making everyone has a sort of level and fair playing field where they understand how to get access to that data.
So I love that term, democratization of data. And when I think about it, to me, it really does come down to the accessibility of these tools and technologies. And we're here at this Space Plus AI Summit, and those are two major, one, of course, a domain, another a technology, but both going through what I would say this democratization moment. Whereas, space, historically was the domain of governments and, in fact, superpowers, if you go back to, the history of the start of the space age. But now you have all this commercial activity with companies like Albedo and others that are now bringing these capabilities to not only governments, but organizations in different sectors and across the entire globe. Additionally, AI is at this moment where lots of people now have access to leveraging the technology. And I think, ChatGPT, which has been, talked about some today, can really be credited for that, for having this moment of now putting AI into the fingertips of everybody. And I guess, one of the things I would close is, something that our CEO, Satya Nadella, said, I believe he said it this week or last week at the World Economic Forum, is that computers provided information at your fingertips. AI is now providing expertise at your fingertips.
Yeah, that's really interesting way to frame it. He has a lot of good quotes. So I think maybe the part I'll kind of layer onto that is circling back a little bit to the edge comments, right? So I think an interesting thing that will kind of arise out of this, we've talked about the huge amount of, maybe we could call it like store and forward, right? You're storing up data and then you're downlinking it and then storing it back on Earth. And there's a certain value that you can derive from those historical holdings. There's another, I think, interesting way to use AI in conjunction with these large number of proliferated low Earth orbit constellations going up, where you have sort of individualized tasking that is AI driven, right? So instead of having to have a lot of expertise on like how to fly a constellation and you need to be a government to do it, I think the tooling has the opportunity to bring us to a point where people can, at a very cost-effective price point, sort of get real data, like real near-term data collected of a particular area. Maybe it's a farmer with their field or something, using AI tooling and enable them to do this type of hyper-local analysis that they haven't been able to before.
When I was at NOAA, this is a pretty interesting use case on democratization of data, because a lot of times if you ask them what they think about that, they'll say, it means everyone gets equal access to it. There's a congressional mandate that requires NOAA to make all their data, all their code, everything freely available to the public. And I asked for the global modeling code about 20 years ago, and they said it's free. Here's a tarred up version of all our Fortran code. It's 9 million lines, and it's hard coded for IBM AIX. So you're going to have to go buy a $100 million supercomputer if you actually want to run it. So just having access to it is not enough. And so for the last probably 10 years, all of their code has been refactored. It's all on GitHub and refactored so it can be run on almost any architecture, which really opens a lot of doors, because the problem was, this code's freely available. And all these university researchers and postdocs and PIs and grad students who had all these great ideas on how to improve the weather and climate model forecast couldn't test their ideas because they didn't have a security clearance. And the only people that actually had the machine which the code would run on was a government agency. And yeah, the code's freely available, but where were they going to run it? And so now all the code's out there. Everyone can access it. I can run it on anywhere from, commercial cloud to my laptop. And it's a force multiplier because now we're seeing the science and research community, the universities coming up with cool new ideas on ways to use the code, ways to improve the code, and they're sharing that back. The other thing is just having equal access to the observations. Well, that's great, but you still need the code, the data assimilation systems, whether you want to run the model or you want to do your training. Now all that's on cloud too. So a lot of the cloud service providers are hosting the data. You can run everything there. There's almost no reason to, this is probably something we should touch on at some point, to move the data around. That's what I've been telling people, just stop moving the data, move your processing to the data.
So that brings up a topic we've sort of touched on a couple times now, and in the panel previous, they were also touching on it, and that is getting back to computing at the edge and doing your processing at the edge. In other words, on board the spacecraft, which does two things. One is it allows faster dissemination of actionable intelligence, but also frees up the bandwidth restrictions that we've always had on the way I think of it as an ops guy, pipes going down, right? So the information that's coming back, as Jimmy Spivey mentioned, coming back to mission control. So all of that information has to come back, from what I'm hearing, in one form, if nothing else, at least in an archive and access capability. But then there's the actionable intelligence piece, which seems to be the domain more of the on-resident or on-spacecraft processing capability. How do you guys see that as requirements, if you want to think of it that way? It's almost like two separate sets of requirements. And what does that mean in terms of how we would apply generative AI, as we were talking about in the back room? And I'll kick that open to whoever wants to jump on that one.
I can go first again. So I think one of the areas I'm kind of tracking right now is sort of how, we've talked a lot about large language models, but some of the tooling that is being built around large language models. So using a large language model almost as a new form of operating system. So, and one that runs very efficiently, right? So autonomous agents are kind of coming out where you have the large language model almost acting like a decision maker on which different tools it might run to do an action. So in terms of applying that kind of methodology into space processing, I think there's some interesting opportunities to kind of rethink what it means to be an edge in space. So you can try to place a processor onto a satellite that also is running comms, and it's also running mission control and the payloads. But you can also think about putting specialized satellites that are almost like floating little data centers, right? And using cross communication links to get data to those processing nodes. So I think as our architectures mature, there'll be more opportunity to do that kind of compute in orbit, and like you said, provide those insights back down.
Yeah. Go ahead.
I'll build on the generative AI piece, and I think that it's really amazing what this technology is doing insofar as empowering others. And I remember when it first kind of kicked off out there, ChatGPT and OpenAI, people are saying, okay, well, it can create haikus and jokes and things like that. But then pretty soon what you saw, Stanford was using it, for instance, and they showed how it could pass the bar exam. And it wasn't just passing the bar exam with the multiple choice, it was the written section as well. And it wasn't just doing average, it was doing at the top 90%. So you start thinking about what these capabilities can then provide for space. And I think that it really goes across all elements of the life cycle, whether you're building. And there's aspects of these capabilities, for instance, on GitHub, there's something called Copilot, where you can actually create code with natural language. Then there's training and testing elements where you're able to look into large amounts of information and then ask questions of it and have that information at your fingertip, or in operations where it may be helping you. We did something, for instance, where we worked with the Defense Innovation Unit to show that intersection of large language models and geospatial information. And if you ask questions and then bring that together to be able to get responses with what's happening on the space data. And I think that that's really where the future lies, is this multimodal aspect where you're going to have these different technologies that are coming together. It's not necessarily just the large language piece. You're going to have the visual piece. You're going to have an audio piece. And it's really each of these coming together.
Yeah, no, that's great. At Albedo, we aren't necessarily using edge processing on our satellite. We kind of believe in the adage, space is hard, so we don't try to overcomplicate things up there, at least for now. But on the ground, really looking forward to be able to using, all the things we've seen come about in the past year, ChatGPT. Maybe as like a silly example, I love playing basketball outside, so once we start being able to image the Earth, want to find all of the undiscovered basketball courts and play on them. So I think, just as Steve just pointed out, like you're using it not only as an existing search function where you're not searching POI data in Google Maps, you're searching, real features that are from fresh imagery, but also using that in another part of the chain. So using this ChatGPT-like function to develop more training data, right? Like that's an easier process instead of having to go through and, one by one label things. You're starting out with some sort of prediction. So I think the integration of these tools that we're seeing and we will continue to see in parts of the chain will really make the big difference. Like, I don't really think it's a, silver bullet or, I think it's change comes in parts.
So from that standpoint, we think about what do I want to know and when do I want to know it is really kind of what we're getting to. And democratization to me almost means, what is the information I want to know versus what's the information Neil wants to know? And they're going to be different. And so having that ability to anticipate what's required for the operator or the customer. In the case that Jimmy brought up in the last panel is, what does the crew need to know? Right. So as an ops guy, that's what I want to know. What do I need to know now, and what do I need to do about it? What do the folks in mission control in an integrated ops center, what do they need to know? And those two things are completely different. But the more we move towards this adaptive capability, we will now be able to deliver actionable intelligence in different flavors. Right. What it gets to. What are some of the challenges that you see in being able to deliver that actionable intelligence? And you can take it either from ground processing or processing at the edge, however you want to approach it. What are the challenges that we see in front of us, and how could we use generative or adaptive AI to be able to help solve some of those problems?
So I can start on that, but one of the things we did, and a challenge sometimes comes down to, like you're saying, there's a timeliness piece of it. There's certain information that's it's perishable. It needs to be known right away. And we did, when talking about edge processing, one of the examples we did is we worked with NASA to bring artificial intelligence on board the International Space Station. And that was specifically a project that we did with Hewlett-Packard Enterprise, with something that they have called the Spaceborne Computer. But we worked with the NASA scientists to use computer vision technologies to be able to rapidly identify if there's damage to an astronaut's gloves after they go on a spacewalk. Because when they're out on the spacewalk, they're using their hands, they're doing different experiments or maintenance on the space station, and any sort of damage to their gloves could be a serious issue to the safety and health of that astronaut. So when they come in, they use the imagery, they take images and can even use video to be able to rapidly identify and assist them in space on the edge to see if there's anything that they should be concerned about.
So that's a great example, having done a few of those myself. There's, and gloves are the worst part because the mass of the spacesuit, most people don't necessarily know that. You put me, the suit, and the equipment on me, it's about 750 pounds mass, and you're working in a weightless environment. You're putting a lot of force on those gloves, right? The ability to basically, what I understand is that you can now scan, just do an image analysis of the gloves and have onboard an assessment of what are the weaknesses in this glove that I need to worry about. And then that information, of course, gets transferred down as more or less, I don't want to say the archive set, but the set that now goes down to Jimmy's mission control team that says, this is the decision that they're making based on this information. And then they have the ability to vote yay or nay, I would guess, on something like that.
Yeah, that's actually really interesting. I think the interplay of, so we talked a lot of, this is a space panel, but we haven't talked a lot about sort of like auxiliary sensors that are in a particular environment, how they can enhance data that's coming from space. So as an example, my dad's actually a farmer and grew up throwing hay bales around, and it was always a challenge, like to go out and be like, okay, the hay's ready, or we're going to cut it today. And do we have enough time for it to dry before the rainstorm comes in? Going back to the weather prediction challenge earlier. And it's also kind of like, when is it dry enough, right? So I was brainstorming the other day with my dad about this, and he's like, why can't I just, you guys do AI, right? Like, why can't you tell me, when to do this? And he's like, I'll put a sensor on my tractor, right? Like, and it's not that far of a leap going from precision agriculture use case into, say, like the tactical environment, right? So I think that is an opportunity that we have to have these AI systems inform kind of like which sensing we can place in situ in an environment that will make that insight that we try to drag out of the satellite imagery a lot easier to obtain. So,
yeah, I've been thinking about this actionable information because in my world, it always comes down to probabilities. And if I'll give you an example, like dealing with a weather forecast, if I was to tell you it's going to be 30% chance of rain, you don't know if that means there's slightly less than 1 in 3 chances you're going to get rained on, or is it 30% of the day and it's 100% of rain for 30% of the day, or what? That, actionable information, when you provide someone with probabilities, is really tricky. I mean, just look, for example, at hurricane landfall or tornado warnings. And people are inherently irrational. There's a study out there, and everyone thought, oh, if we could extend the lead times in tornado warnings, we'll save more lives. Well, it's actually not true. If someone thinks they have a lot of time, they may think, oh, I got 20 minutes. I'll go get my kids out of school or something, and they'll get in their car and get caught on the road. And so translating information, particularly probabilities, into actionable information, by that I mean a decision that we hope someone would make to protect themselves, to me is a big challenge. And even though we've been talking about edge as it is applied to space-based capabilities that initialize these models, I think there's another use case that we'll probably see coming here soon. And that's once we have the capability to replicate these forecasts using AI, that runs on such a tiny fraction of compute, you could literally do it on your phone. And then you have the opportunity for a phone that knows your habits and your location to have a custom tailored solution with you at all times. And that's where you're going to get your information from.
Yeah, I love that example. I think as, I see the value chain as, we start with the sensor, which is where Albedo's at. And at the end, there is the value provided to the end user, the customer, right? So it's a big value chain. And as much as a seller of satellite imagery would like to say we're the only piece of information you need to drive that actionable insight decision, we aren't, right? You need to combine all of these multimodal sources of data. And to put it into context, if there's a hurricane coming, that's not the same, and the decision you want to make is, when should I leave? That's not the same decision for everybody, right? Like, if I'm a single person and I live alone in an apartment, I can just pack up and go. But if I have a family and 6 kids and a small car and a dog, how am I going to fit everything in the car, right? And I have to leave and plan and pack earlier. So I think you need people in the middle of the chain to provide that value, that additional translation, to make it specific to the end user. And there's a degree of generalization that you can do, but in the end, it has to make sense for the end customer.
So really that gets down to, when you look at the whole chain, as you were just mentioning, Winston, and you want to democratize the information to each of us individually on this panel, for example. It depends on what is it that I want to know and when do I want to know it. And so there's an in-between step that seems to have to exist, right? That's now looking at patterns of your behaviors versus my behaviors, and then tailoring that information so that it becomes ingestible by the end user, the customers.
If I can build upon that, because it does come to down to your data, as you're saying, and we're here in the nation's capital, a couple miles from the White House and from Capitol Hill, and there's a certain amount of public data that we've talked about before, certain satellites, but then there's data that is not going to be public. For instance, we had panelists up here earlier from the Department of Defense, from the National Reconnaissance Office, and the intelligence community, and they're going to have data that they are going to need to keep at the right security classification level, and keep only to those that have access. And what's really interesting is these capabilities. So, for instance, Azure OpenAI, which is based upon the GPT AI technologies, enables enterprises or government to be able to protect their data. So it's not just using the large model that's out there, but being able to ground it with their own data. So they're getting insights from these models based on what they're putting into it. To include those models, and we announced late last year, those capabilities are going to the classified clouds. So governments are now able to bring their data, or the U.S. government in particular is able to bring their data and specifically be able to have the benefit of these technologies with it.
So one thing we haven't really touched on yet today is the term digital twins. And so what I'm becoming aware of is that when we talk digital twin, we might have 5 different opinions on what a digital twin is just on this panel alone. So in terms of the application of a digital twin, first, what does a digital twin mean to you? And then second, what does it mean to your customer? How do you see the digital twin being an application of the generative AI support that allows you to drive to a true digital twin? And where do you see some of the challenges and some of the risks associated with those?
I could go first.
Brent?
We happen to have a whole suite of products around digital twin, right? So I sort of decoupled them in my head from generative AI, and I think as the months kind of tick by, they start to kind of merge together more and more. But we do have a tool called Omniverse at NVIDIA that was kind of came into fruition over quite a bit of work internally and quite a few years before I was an NVIDIAN. But to use the term we use. But yeah, the Omniverse metaverse concept kind of was out just a little bit before, I would say, the big splash of generative AI. And it, at least from my perspective, I support the DoD and the federal sector and NVIDIA, and I see it as a really enabling tool to take a lot of things that we do physically in the world today, things like testing, testing eval, and bring that into the digital world. And there's a lot of advantages to that. So, we can iterate more quickly as we kind of we call it the real to sim gap, as we kind of like close the gap between reality and the physical world. We're able to kind of iterate and create our systems and test them a lot more efficiently and safely. And then, as AI starts to permeate that ecosystem, we're starting to see some really compelling things happen. So NVIDIA actually created this tool called Chat USD. I won't get into the weeds of what universal scene description is, but it's essentially a way of creating this general file format that can encapsulate this 3D virtual world. And so it's a language like any other, and it's possible to train generative AI to understand that language. So there's a lot of kind of fascinating tech capabilities that are coming out of that, where you can do things like describe, like if you're in the DoD and you're trying to do a mission planning to go rescue a sailor that's stranded, you can actually leverage these AI tools within this virtual world that's grounded in the physics of our world, and come to a rapid answer on what type of solution you might want to approach, like which helicopter platforms are most suitable, and if that doesn't work, backup plans. So that's kind of what it means to me, is just at just the beginning here, but like being able to do things a lot more efficiently and rapidly and safely.
Steve, do you want to touch on that?
I love where you went with that, thinking of digital twins plus artificial intelligence. I would expand that to then plus cloud computing, plus augmented reality. And it's really the intersection of these different technologies coming together. And the hardest use cases is where things really start getting interesting. And, I would say that that's the type of stuff that we are working on. In fact, the Space Force recently announced a contract that it has with Microsoft called I3E, Integrated Immersive Intelligent Environment. And that was a follow-on contract to the initial 6 months, where we demonstrated some capabilities to include things like, how do you have a digital twin of the International Space Station? You bring that telemetry down. You're then being able to visualize and understand that in an augmented reality environment. You're then able to bring artificial intelligence tools to understand when anomalies or situations are happening to it. You're doing it in a cloud environment that expands beyond a physical location, but to multiple sites. And you can start seeing the integration of these different technologies addressing use cases in ways that really never have before.
That's an interesting one. Let me follow that for just a second. So when you mentioned bringing the environment of the space station down to the ground, for example, I could conceivably see how a mission control architecture could now adapt to that, particularly as Jimmy mentioned, the farther out we go in space, the longer the latency is going to get. And when we talk about distances to Mars, we're looking at 40 minutes round trip potentially when we're at 250 million miles, and 2 weeks of occultation, where unless you have relays, you're really out of communication. So having that capability, say in mission control, would allow, with enough fidelity, a mission control architecture to operate on near real-time capability, even though they are 40 minutes away, so to speak.
And JR, I would expand it into, it's not only mission control, but it's those people training and learning before they're going to mission control to be in those environments. And then it's people building. It's people building the next generation of the system to actually be figuring out what the next requirements are, what the features, what the new things they're going to add to it. So it really ends up, these technologies that we're talking about do end up transcending across them. And probably the most important thing I think that I would say today to encourage this audience and anybody listening is, how are you getting involved? How are you leveraging these technologies? How are you experimenting with them? How are you getting your hands on them? There was a Fortune article in the last week or so, or maybe a couple weeks, that the headline caught my eye, which was essentially AI might not replace your job, but it will definitely become your coworker. And the thing I ask you all, is it becoming your coworker yet? And if it's not, why not?
I think there's a use case with the digital twin that really applies to satellite observations in space. And I'll give you some background on how we used to do it. It would be design a satellite, launch it into space, pull down the data. Let's say, for example, there's a 10-year usable lifespan of this instrument. Well, it may take the scientist 5 years to figure out what to do with the data, how to quality control it, how to optimize it and use it in the model. By the time it actually is providing a positive impact, the lifespan of the instrument on orbit's half over. You could eliminate that process by just having a digital twin of the Earth. And you can synthetically extract data on the ground using your digital twin and simulate what the satellite would produce, feed that back into the models, and optimize everything before you even launch. To me, that is one of the most exciting use cases. And we've done these experiments in the past. We call them observing system simulation experiments. But they've always only been as good as what we call the nature run, which is sort of our best guess of the atmosphere, which is orders of magnitude more crude than a really sophisticated digital twin. And so that's where I think, at least from my world in Earth observations, an exciting use case of digital twin.
Actually, I just need to jump in real quick.
Sure.
I actually just got an email before I got on the panel that they were releasing access to Earth 2.0. So jump on Earth 2.0, where we're actually pursuing that actively. That's something that our CEO is really passionate about, of kind of building a supercomputer that would be able to simulate the entire Earth at a reasonable, useful resolution. And I know that watching the engineering teams iterate over the past 6 months to a year, a lot of that was figuring out how to pull all these feeds into that. So yeah, that's something that jumped out.
Well, unfortunately, we could go for another hour on this, but we're running out of time. So we want to make sure we do have an opportunity for questions. So if you have a question, raise your hand and come to you.
Thank you. Good afternoon. I'm Sandra Irwin with Space News. I have a question for Steve, Kitay, or if the other panelists would like to weigh in as well. It's about the Department of Defense and their initiatives with AI. We heard that they're doing a lot with trying to promote AI, trying to increase use of AI. Even the Secretary of the Air Force said we need more tools to analyze all the data, like all the things you guys just talked about. So, Steve, you mentioned this Azure GPT tool that the government is using, but is that the solution to the DoD problems, or why is this continuing to be a problem given all the technology that's available? Why are they not using it at the scale maybe that they should be using it? Thanks.
So it's a great question, and speed and adoption of these new technologies can often be a challenge. Not only, I would say, with the Department of Defense, but in the United States government writ large. But we are seeing great people, great leaders that are trying to promote the speed of adoption and recognizing how much these new tools and technologies, for instance, Azure OpenAI in the Air Gap Cloud, can help empower their workforce to achieve more. I would say, we're getting there, but I think there is a lot more work to go to get that speed of adoption. And then it's moving from demonstrations to scale global capability. Because at the end of the day, if we're talking about the Department of Defense, you need to get the capability into the hands of the operators who are trying to deter conflict, maintain peace, and if peace fails, that they're prepared to win. So it's making sure that technologies get all the way out to them and it gets beyond that demonstration. So I would say that there's pockets where we see it happening, which is exciting. But I think, overall, we are looking for more adoption and faster speed. And, I think that it's not just Microsoft, but there is an ecosystem of innovation, Albedo, NVIDIA, Booz Allen here. In fact, actually, they've got some really exciting stuff I saw in the back. And it's helping the department leverage these across the board.
We'll get to it.
Do you have any examples of digital twin gone wrong, or like what are some common mistakes that maybe to look out for that sort of thing?
I could do a quick. I see lots of signs flashing at us, so I'll try to be brief. So I think I'll just talk to some of the challenges of digital twin. We talked about the opportunities. The things that I see come up over and over again is, we get very excited about making this perfect replica of a facility or the whole Earth, but we'll just say this building. The reality is you have to have a pretty broad skill set on your development team to make that happen. People who are experts at 3D design, getting all these lights with these swishes in here. The buildings, the material attributes that are closing that sim to real gap is a real challenge. Making sure you get the physics right. And then typically, as soon as you move out of RGB, visible, that's pretty well described, into infrared or different sensing modalities like RF or radar, the challenges become compounded. So I think those are some of the things that are starting to be addressed, but those are hopefully gonna kind of mature over time.
Okay, I want to thank our panel. It was a great opportunity to have this discussion with you today. And thank you very much for joining us here at Booz Allen. We really appreciate your insights today. It was very helpful. Thanks very much.